In this lesson, we're going to take a look at the glossy reflection shader. So if you open up the start file for this lesson and just take a quick render, you'll see that we really just have a sphere that's right now in some kind of an environment. And this will let us see the reflections that we're about to apply. Now for the moment, this sphere is just using a standard mental ray Phong material, so there are actually no reflections whatsoever on this sphere. So let's start to introduce some glossy reflections onto this. So this can be found inside the mental ray node's materials, and we're going to add the glossy reflection. Now if we double click on this, all we have to do is take our Phong shader or any of our mental ray base shaders, middle click, and drop it into the base material slot. Now this glossy reflection shader can actually be applied just like any other material. All we have to do is just middle click and drag it onto our object. Now you'll notice that the first time we render this, that we actually still don't see any kind of reflections that have been applied to this. Now that's actually completely normal. All we have to do now is take a look inside this glossy reflect node and start to adjust some of these parameters. So the first thing that we need to adjust is the reflection color. Right now this is set to black, which basically means we have no reflections. As we start to dial this up, we should now start to see the effect of the reflections beginning to appear. And now this starts to become much more apparent. So by just simply altering or lowering this reflection color, we can basically control the strength of these reflections. And you can see right away that they already have quite a bit of blurriness that has already been applied. Alright, so just below that we have the max distance. Now this will let us start to filter out objects that are beyond a certain distance from our object that we want to start to have these blurry reflections. So this is really just kind of an optimization thing. If we start to have objects that are very, very far away from the object that has these blurry reflections, we can really just tell mental ray not to calculate those objects if they're beyond a certain distance and still keep our render times relatively fast. The fall off really just determines how quickly we actually reach whatever this final distance is that we've determined. So with it set to a value of 2, if we're basically using a squared method, or rather an inverse squared, so the actual ray will start to lose its distance relatively quickly, and it will actually probably lose most of its intensity by the time it reaches this value. With it set up to a higher value, it will fall off a little bit faster before it reaches whatever final distance we have set. Now the environment color, this is so that we can start to override whatever it is that is going to be reflected. Now right now we're just using a simple piece of geometry as our reflection environment. So really there's no need to come in and start to alter this environment color. Now just below this we have the ability to control independently the reflection base weight and the reflection edge weight. Now what this is controlling is the reflectivity of the object at its point that is most directly facing toward the camera. That's the base weight. So any of these areas of the sphere that are most directly pointing toward the camera only have a reflectivity level of 0.6, whereas these areas that are further out around the edges only have a, actually they have a higher level of reflectivity. So this actually will start to become a little bit more apparent if I were to set the reflection base weight all the way to 0. And now you can start to see these areas that are most directly pointed toward the camera have no reflectivity whatsoever. However, these areas that are facing outward away from the camera actually have a much higher level of reflectivity. Now this edge factor controls how quickly we actually sort of blend between this edge weight and the base weight. So with this lower edge factor, you can see now that we go through a much more rapid transition from this base reflectivity out to the edge. You can see how this edge is now choked in much, much further. Alright, so let's set this base weight back to something like 0.6, so that way we can start to get a little bit better idea of the actual spread and samples values. So the spread really is controlling the amount of blurriness that we get on these reflections. So right now with this set to a value of 0, we should really get no blurriness whatsoever on these reflections. Likewise, as we start to increase these to a much higher level, these reflections should now start to become even blurrier. And that's exactly what we see. Now you will notice that a lot of these reflections, once we start to introduce these, there is actually quite a bit of noise that's present around these outer areas of the reflection. So what we can do to soften that out is to begin increasing the number of samples. So this is a really nice way of being able to kind of eliminate some of the noise in our scene without having to go into the render settings and adjust the aliasing levels for the entire scene, which would really slow down our renders. Instead, we can now keep our renders moving relatively quickly by just simply increasing the samples for this shader and not having to worry about oversampling the entire scene. And you will notice that that now starts to eliminate a lot of the noise and the speckling that we had on these blurred reflections. Now you will notice that we do have independent control over the horizontal and the vertical spread. So with this, we can actually start to get a little bit more of a brushed metal type of appearance. So if I were to take the vertical spread, let's say to a very low value, and start to really increase the amount of the horizontal spread, you can see how that now starts to give us a lot more directionality to this blurring result. Now we can actually start to angle this direction of the blur by increasing the U and the V axis. So right now, if I were to orient this more toward the y-axis, these are referring to x, y, and z coordinates. This should now start to change the overall angle of this blur. And you can see how that's now oriented along the positive y-axis. And that starts to now, as I mentioned, start to give us these blurring effects that now run much more vertically along this surface. Now this does work best if you're using some kind of a NURBS type object, something that does have these built-in U and V values. Polygon objects are not particularly good for this. Now finally, we have the amount of dispersion. Now this is basically starting to introduce a little bit of an effect called a chromatic aberration, which will let us start to kind of break the reflections apart into different parts of the spectrum as they are blurred out. So this might become a little bit more apparent if I were to lower these values. And let's start to increase this dispersion. This is something that goes from a value of 0 to 1. 1 meaning we get full dispersion. And this really is a fairly subtle effect. But if I save this image for comparison, and then go back and drop this dispersion back to 0, you can start to now see just a very subtle difference that we get as a result of using this dispersion. So we start to take some of these brighter areas of the spectrum, some of these yellow areas, and begin breaking these down into a little bit more of a green area of the spectrum. And same with some of these orange areas. We start to now kind of break these apart into some of the different rainbow effects that we get. Alright, so that's a look at how we can start to utilize the glossy reflection shader as a way of introducing reflections to our base shaders.